Welcome to Study Loop.
Okay, so in this question, we want to prove various properties. So we'll start off with A. If, x is less than or equal to n, if and only if the ceiling of x is less than or equal to n. So I'll prove this implication first. So if we have x is less than or equal to n, well, we know that x is always less than or equal to ceiling of x, right? This is just pretty much by definition. So therefore, you have x is less than or equal to n. Very simple. Now, if I suppose that x is less than or equal to n, well, we use a bit of logic here. We know that x is going to be less than or equal to ceiling of x, but the ceiling of x is an integer, which is the lowest integer, which is higher than x. So what this means is, if we have x here, then either ceiling of x can be right on top of it, or it'll be the next integer closest to x. But what we know here is that x is less than some integer n. So the integer could be over here, it could be over here, it could be over here, or it could be on the ceiling of x, right? But the point is that ceiling of x is the lowest integer, which is higher than x. And we know that n is an integer higher than x. So therefore, ceiling of x must be less than or equal to n. So we've proved the rightwards implication. So therefore, x is less than or equal to n if and only if ceiling of x is less than or equal to n. Now, next question. N is less than or equal to x if and only if n is less than or equal to floor of x. So I'll prove this implication. So if n is less than or equal to floor of x, then once again, by definition, we have floor of x is less than or equal to x. So just combining inequalities, you have n is less than or equal to x. Now, proving the right implication, we will use the same logic as before. We know that the floor of x is an integer lower than x, but the highest integer lower than x. So if x is right here, then the floor of x could either be on it if x is an integer, or it would just be right next to it. So what we know here is that n is an integer which is lower than x. So once again, n could be somewhere here, n could be somewhere here, n could be somewhere here, or it could be floor of x. So then the reason why n must be less than or equal to x, because n is an integer lower than x, but ceiling of x is by definition the highest integer lower than x. So therefore, you need to have this inequality. So since you have both proofs, both directions, you have if n is less than or equal, so n is less than or equal to x, if and only if n is less than or equal to floor of x.